what you're looking at unless you see it in front of you. Now, according to your sketch, this is perfect for your point of discontinuity. We factor, we look at the bottom denominator, the bottom factors, that gives us our domain. Don't eliminate that first. Get your domain. So I can't use a 3, I can't use a -5. So I remove that from my domain. Remember how we did it? Like a number line, right? Okay, hold off on the range. Now, the factor that you can cancel out is your point of discontinuity. So as soon as you cancel out a factor, make yourself a point of discontinuity. I'm supposed to be serious. This is serious. Yeah. Okay, point of discontinuity. Once you factor this out, rewrite this. You need this part to work with the rest. So now, when you get to your point of discontinuity, now you can put your 3 in here. This is where your limit comes from. So if I say this function, what is the limit as x approaches 3? You say, I can't put 3 in here, right? Remember we did this way, way back, and I'll show you in 1 second. But we said, if I could fill in this point of discontinuity, if I could fill this point in, what would it be? And if you remember, we looked at the graph too. We came from this side of it, and we came from this side of it. And we did like 2.99999, 3.00001. And we said, oh, it would be 1/8. And 1/8 is what we get when we substitute it back into here. This is called a removable point. This is your point of discontinuity. When you look at your graph, you can't even see it. It goes right over it. Right? It looks like it's continuous. On your table, however, it will say 3 is an error. It will say -5 error, 3 error. What's left over here in this denominator is your vertical asymptote. That we cannot eliminate. So your vertical asymptote becomes x is equal to -5. God bless you. Now, your horizontal asymptote says the degree in the numerator is less than the degree in the denominator. My horizontal asymptote is y is equal to 0. So you're at the y is equal to 0 here. Somewhere I put this. Here it is. The degree in the numerator less than the degree in the denominator. You are at the y equals 0. Get your asymptotes there, and then graph your function. So your function is traveling like this, traveling like this. This has no max, no min.
How did you get to the intercepts x equals 0, y equals -3?
Okay, hang on to that 1 second. We'll get to the intercepts. I just want to get through the rest of this. So everybody got their asymptotes down pat? Okay? From this now you can do your range. Because this point, when you come from your y, you're coming up to your y, you got stuck right there at the y equals 0. You can't use y equals 0. So you jump over it. We jump over it. However, there's a little point of discontinuity. And that point of discontinuity has a y value. You can't use that y value either. So you got to jump over that little y value and then continue. So start with your domain first. Factor, get your domain. Reduce your function. Once you reduce your function, look at your vertical asymptotes and horizontal asymptotes. Excuse me. And graph it. Find your range after that. Now our intercepts. Our intercept, our y-intercept, when x is 0, I just went up here. I plugged a 0 into here, 0 into here, 0 into here. I got -3 over -15. Is that the one you were asking me about, Amanda?
Yeah.
So plug a 0 in here, 0 in here, 0 in here. -3 over -15. And I just reduced it. Okay, your x-intercept, now we can tell there's no x-intercept, but show me somehow. If I plugged in a 0 and I cross-multiplied this, obviously this is not going to work, so there's no x-intercept, no real x-intercept here. Because your y equals 0 is your asymptote. If you even say to me your y equals 0 is your asymptote, I'm okay with that. Yes.
How did you get the range? Like, why is it?
The range comes from here. We're coming up to your y. I can use everything until I stop right there because this is y equals 0. That's an asymptote. You can't use that one. God bless you. You can't use a 0. We have an asymptote here. And we can never go through the asymptote. Not, we can, well, we can.
So when you go negative infinity to 0, 0,
Negative infinity to 0.
and 0 to positive infinity?
Well, almost, but there's a little point here. That's your point of discontinuity. So as you go through this graph, see it's going like this, and it's coming along this line. There's a little point right here where y is 1/8, where you can't use 1/8. It would be removable if we could. We can reach that limit, but we can't forget that it's not there. So I'm going to jump over the 1/8 and then continue. That little point is going to stop us. That little point is also here. Isn't it in your domain as well? Did you take out 3 from your domain? You should have, because this is part of your restrictions for your domain, right? So who belongs to 3? 3 is 3 and 1/8. So if I can't use 3, I can't use his y either. After you reduce it down, plug it back in. After you reduce it, because if you put 3 in the beginning, you get a 0 in your denominator, so you can't do that. So eliminate it first. Good? That's all there is on this one.
Yeah, no,
Okay, I'm going to hit the next one.
What do you say for the limit?
So the limit, as I reach 3, what is my limit, my y value? My y value is 1/8. Like, where is it going to converge if I could do this? And remember we put this in your calculator? We put it in your calculator. Let me put it in your calculator. Oh, I hate doing this. Oops, let me do it from here because I can't. All right, let's put this in your calculator. Guys, just work with me here 1 minute, because this is important that you remember this, because this was a while ago. Put it in your calc for me. Automatically should grab a calculator. Yes.
You have any more questions that are like on this?
That I made up? No. Okay, here's my graph. Guys, watch. Here's my graph. Your graph should look like this. You can obviously see the break where x is -5, right? So when I look at my table, I say, okay, yeah, -5. I can't use -5. But when I come down here, I can't use 3 either. 3 is an error, right? If I did second calc and I looked up what's my value for 3, I have no value. There's no point there. God bless you. It's a point of discontinuity. However, watch. If I do this, and we did this back like September probably, if I look up a value and I look up right next to it, 2.999, oops, it says 12 point. 2.9999. Keep going with the 9s. Real close. Watch. I get 0.125. 0.125 is 1/8. So if I could reach that point, if I could track it and fill that in, that's what that point would be. So I can tell by my graph, and I can tell because I can plug it into what's left of my function once I reduce it. I came from the other end. I see how close I got? This is 1/8. 0.125. Okay, so this is called a removable point. We talked about this back in September, October. Yeah. I said we revisit them again. We do. And you will work on these next year as well. Okay with this one? Now, as x approaches infinity, watch what happens as x approaches infinity. Here's for this one. As x is approaching infinity means as x gets higher and higher over here, what's my y value? So right now I have an asymptote. if I could eventually reach that asymptote, what would my y value be? 0. Isn't this the same as your horizontal asymptote? Because isn't infinity just describing your end behavior? What's happening at the end of this thing? Where am I going with this? Where is my graph going? My graph is going on and on and on. And we do your horizontal asymptote because that helps us do your end behavior. But it also can be called the limit. As x gets larger and larger and larger and larger, what's stopping this? The y equals 0. Eventually, I'll be like 0.0000000000001. So I'm very, very close to the 0. So you can write a limit this way too, to infinity. Your infinity, your limit to infinity is just your horizontal, or whatever asymptote you have. I should take that back. Could be a vertical, could be a slant. But whatever asymptote is that's guiding that, that's what's guiding your limit. Okay? All right, let's hit the next one. The next one's a little trickier. And I did rewrite it, but somehow it's off my board. So here's the graph for this guy. X plus 5, again, this is it. Now, once you graph this, you don't exactly see it. You see one part of it. If you remember, there's probably another part to it somewhere, right? Because of this asymptote. Doesn't this asymptote mean something should come to the left of it, something should come to the right of it? So when you graph it with your 10 by 10 window, you don't see the whole thing. So put this guy in your calculator and make your window go from negative 50 to positive 50, both your x and your y's. You can make your x go negative 30 to positive 30. Make your y go negative 50 to positive 50. You're not going to see it. You're going to see one little piece up there somewhere. My board is off, so a little bit over here. Okay, so you're only going to see this piece up here somewhere. You're not going to see this unless you change your window. But when you have an asymptote, that said, your x's were coming along doing just fine until they hit a wall. They can never cross a vertical asymptote. They can cross a horizontal asymptote. You don't have anything on your final that crosses a horizontal, so that's a good thing. Because if you remember back, we had to find the minimum for that. It crossed over, but then it came back and followed the asymptote. It followed your end behavior. Your asymptotes are designed to help your ends behave nicely, to have something to follow. Kind of like the hyperbola. Why we draw those? Because we need to know where we put the hyperbola. Okay, this one doesn't factor, doesn't reduce, and it looks something like this. This one does have a max and a min because it loops like this. It also has concavity because it loops like this. That had concavity also, but you don't have to worry about the concavity part. This had a concave down, this had a concave up, but we just would have to jump over that point. And increasing, decreasing, everybody okay with the increasing, decreasing parts? Okay. All right, so when you get down to here, we take your domain. Now your range you can't find yet because of these two things. So find your relative max and your relative min. Did you find your relative max and min? And they're relatives because they're not the lowest or the highest. So you remember how to do it? Okay. Second calc, do a max and a min. Just move your little cursor back and forth. That's the easiest way. The min is the top one, yeah. That's your minimum point. Your maximum is the bottom.
How do you get to the bottom one? Oh, I got it.
Just keep moving your cursor and it'll flip over. You probably just don't remember doing this. We did this so long ago. So if I graph this with this window, all I get is this with your 10 by 10. But you have an asymptote here, over here, which means there's got to be something living on this side. So you're going to have to look. If you look at your table, guys, you can see you have values over there. So they're there. It's there. You just can't see it. So if you changed your window, just make your x negative 30 to positive 30 and your y. Just play with your window till you can see it. And make your y a little bit bigger, 50 by 50. I just made it 50 by 50. Okay. See it down there? Now, do you see something that's making this go a little slanted? There's your slant asymptote. If you put your slant asymptote in here because you divided, you synthetically divided, it became x minus 9. I'm just going to put it in. Watch your slant asymptote. See it? See it working? You can even go through a slant, but this one doesn't. Now, your max and your min, second calc, everybody is able to find it. Just do this. If you're there, go to the left of it. Easiest way, just go to the left, hit enter. Go to the right, hit enter. Make sure you pass it to the right enough so that it comes back up. And hit guess. Give me 3 decimal places. Remember 3 decimal places? And you should be okay with that. So we have a max and min. Max and min you're going to need so that you can do your range as well. So your range is going to come up here from infinity. So negative infinity. It's going to stop at that y value, negative 27.711. It's going to jump over that y value, God bless you, and then it's going to stop at this, restart at this y value, negative 0.289, and go to infinity. You have a slant asymptote because the numerator is 1 less than the denominator. So you're going to synthetically divide, ignore your remainder. The numerator is 1 more than the denominator. 1 more than, yeah, so that tells you slant. That's a 2, that's a 1. I did? Oh, sorry about that. So the numerator is 1 more than the denominator. Synthetically divide, just get rid of your remainder. And that's a y, it's got to be a y equals. There's no point, no, because you didn't factor anything out. If you don't factor anything out, you have no point of discontinuity. Generally, these don't.
I'm not getting the same maximum.
Okay, let's see what you're doing. Make sure you go enough past it and enough past it this way. Ah, yeah, you gotta move it. No, it gives you that little, you gotta hit enter 3 times, but you gotta go to the left and to the right of it. You gotta isolate it, and then what your calculator does is this, it gives you these little arrows like this, and it's looking in between there, wherever you tell it to look. Okay, questions on this? Everybody okay with this? This has concavity. Again, it has increasing, stop, decreasing, decreasing, stop, increasing. We're good with the increasing, decreasing? Okay. All right. Which one did we leave off on?
Oh, wait, what is it?
Number 9. Okay. End behavior. End behavior is asymptotes. Remember, end behavior, what guides your end behavior is an asymptote. It doesn't always have to be a line. It could be a parabola. It could be a cubic function. It could be anything. It'll help guide. If you graph this, you'll see it. So we'll usually say divide synthetically. God bless you. So again, you have, God bless you, you have a double on the bottom here because your leading coefficient is 1. So take them out the opposite way. Ignore your remainder. Not when you're finding your end behavior, your asymptote. When you synthetically divide, and you're absolutely right, when you synthetically divide, we did the one before, that yesterday, it just said divide synthetically, and then your remainder does go over the denominator. But remember with our asymptotes, we get rid of the remainder. with any asymptote.
So basically, what I said is having the end behavior at the same time and the same asymptote.
Any asymptote will determine your end behavior. Your horizontal one says where it's going to go. Your vertical one will say where it's going to go. Your slant one, it will say along your slant. Your asymptotes are designed for your end behaviors. So just ignore the, let me get my line over there. Ignore your remainder and make sure you can do that. Looks better today, right?
It's supposed to be a 5 on the, instead of a 3 on the first row. Before the negative. For the coefficient.
It's supposed to be a,
Oh, yeah, it's supposed to be a
No, on the top.
On the top.
Coefficient.
oh, you're kidding.
You got the right.
Oh, okay, I just copied it down wrong. Okay, thank you. End behavior is what's happening to my graph. Okay, here. Parabola. Where are your ends going? They're going up to infinity. Keep on going. Nobody's stopping them. They're going to just reach whatever they like. All of a sudden, I throw an asymptote in here. And I throw another asymptote in here. Now what's my end behavior doing? Whoa. It can't go past this. I'm guiding this where it's going. Same thing with your hyperbola. You know when you make your hyperbola, you make a box. How do you know where to graph your hyperbola? You use your asymptotes. Technically, I'm guiding your ends, right? Asymptotes are just there to guide your ends.
So what does end behavior basically define that?
Asymptote.
When you're writing out the equation after you get the answers, how do you know to start with execute?
Because you go like this. Real basic. x5 over x2 gives me x3. Just say it real basic to yourself. Front ends, just take a look at your front end. Okay? Alright.
So that equation, that is just the end behavior?
Just give me an asymptote. Whenever it says asymptote, just drop your remainder. Mm-hmm.
We're not going to have anywhere where you have to synthetically divide with a coefficient in front of the x squared is like 1/2 or like something like that.
Yeah, you could, but you don't have it on your final.
Yeah, that's right.
Yeah.
Okay.
You might have one that has a 3. You might have to. You do have a double divide, but you don't have one where you have to factor it out. You do have the ones that we've been just doing.
So
With the 2 factors. You have one of those. You have to factor it out, and then when you get your factors at the bottom, you have to divide it out of there. Don't worry about it. Don't worry about it. Don't get confused with that. We did this one, right? Yeah, you sure? Okay, asymptotes for these guys. This has, when you factor this, okay, factor. Okay, you're going to take this out. This is a point of discontinuity. It's not an asymptote. What's left is this asymptote, and this rule is this guy. So now if I said to you, what is the limit as x approaches infinity, you would go to your horizontal asymptote. You would do the same exact rule for this. The numerator and the denominator have the same exponent power. So I make a ratio. And I don't say y equals, I just say 1. Because isn't this my y equals 1 line? It's going to somehow guide the end to go like this. All it's going to do is guide that end behavior. It would be 1. No, I'm just saying, like, if I asked you what the limit is, why wouldn't my answer be A? Because this is a point of discontinuity. This is not an asymptote.
How do you know the difference?
Because when you factor it out, that point comes out. First of all, I graph it. If you don't look at the graph, it's going to be tough. Look at the graph. You should see 2 breaks. You should see a break vertically one place. You should see a break horizontally one place. Now this guy here, he's not an asymptote. In your table, he's an error, but he looks like it's written right over. To me, the easiest way to do that is to graph it. You guys don't like to graph. Okay. And then we did this. Did we do this one? Yeah. Huh.
Yeah, we did.
And it still gave me a hard time over there. That's weird. Someone goes for the one above it. That's weird. Okay. And You didn't have to do that one. You had to do 15. 15 is a nice one. If you remember back when we had polynomials, we said 4 roots, 3 terms, 2 inflection points. So you started with, you had to use your calculator to find any 2. Even if you could find 3, you could keep dividing. I don't care. But at least find 2. So synthetically divide those out, keep on dividing until you reach x squared. X squared you can factor. There was one more, there was another 1, but you didn't really see it. So you can, if you found it, you can divide again by 1 and then come out with the 1/2 at the end. If you wanted to do that, I'm fine with that. If you just get down to the square, you can factor and just find your roots. There were 4 roots and we only showed 3. That's because 1 is a double. So if you graph this, if you put this in your y equal, you're going to see at the 1, it bounces off the axis, right? It doesn't go through it. When it bounces off your axis, it's a double root. So technically, there are 4 roots there. Okay. Was this it for this one? No? Yep. Yep. This was like, this is a big part of it, so I don't mind us going over this a little bit more because this was from a long time ago, and you guys were really good at this way back, but it's just been a while since we've done these, so I get it. And I would maybe over the weekend just go back and review your functions a little bit more, because you'll get more comfortable. You'll remember that we did the asymptotes and the end behaviors. And I'm sure you'll remember this because this was always like a fun one to do. Divide, divide, divide. You could even divide by another 1. The 1 is a double root. Even if I went through here and I divided again by 1, by another root. Remember, every time that it is a root, you have to get a 0 as a remainder. Remember that? So here's my last one. So this would be 2x minus 1 equals 0. And x would be 1/2. If you spotted that that was a double root. The only way you're going to spot a double root is to look at your graph. Because in the table, it's only going to appear once. But if you look at your graph, you'll see that it bounced off the axis, didn't go through it. And then you could do this division again. You good, Chris? Okay. And the last one was 17. And behavior again. And behavior just says, give me an asymptote. So if I look at this guy, this is not a horizontal because the top is bigger than the bottom. It's a slant, but it's not a line. So I'm going to just synthetically divide this. Now, be careful on this one. Watch. This is a tricky one. I have a leading coefficient of 1, but I'm missing my middle term. So make sure you just work this out and use your middle term. So you're going to divide by this.
I'm getting from the division.
Division? Sure. So start with this. 3. Make placeholders. 0 gives you the 3. The third one. The second one. -2, 1. Now, to get your denominator out of there, you have to expand that. Because technically there are 3 places down there. The middle one just has a 0. Your leading coefficient is a 1, so you don't have to factor anything out of there, but you're going to have to take these out the opposite way. The 0 only comes out one way. Now, you're going to do it the same way you normally do this, but you just have to do it twice, technically. So start from the left, go to the right. 0 times 3, 0. Then you got another one here. -1 times 3, go to the right of that. -3. And stop. Just add down the first column closest to you. Then do it again. 0 times 0 to the right. -1 times 0 to the right. Add down the column closest to you. Okay. 0 times -3, 0. And -3 times -1, 3. Now you're done. Add them all down. Okay. Now, your end behavior, if you're looking for synthetic division only, then that is a remainder. The negative 2 and the 4. If you're looking for end behavior and I want an asymptote, you don't want the end, you don't want the remainder. How do I know where to start? x4 over x2 gives me x2. So this is 3x squared plus 0x1 minus 3, and I don't care about my remainder. So you have a parabola that actually guides this endpoint. If you want, put it in your y1, put it in your y2, and see that it's working. See that it works.
If you had them where you start at something else at the bottom, like the leading coefficient,
Yeah.
what do you do?
So you're going to hold the factor aside, and then after you get this down here, you're going to divide by whatever you divided, whatever you took out of there. Like if you took a 2 out, then take a 2 out of here. Yeah. You actually don't have one. What was the next sheet that you guys did? 6. Let's see if we can just like, we didn't go over 5. 5, there's 2 questions. Let's do that. Wait, we didn't do 5? We did 5. Okay, and so 6? Okay. This was easy, right? Graphing, make sure you show the orientation. I think there might even be a 2-point problem like this, but you guys need to graph and show me orientation. And then we'll eliminate one. Remind me on Monday, let's eliminate this algebraically.
How do you know if you use the P1 plus R over N or per?
When you're on number 2? Okay, so you have 2 formulas. I put them on the top. The first is continuously. The first one is compounding. And I wrote annual is 1, so you really don't need the fraction if it's a 1. Then quarterly is 4, monthly is 12, daily 360, and on the bottom there's your PERT. And money is always 2 decimals, automatically. Round to your money. Are we okay with that? Was that the only 2? N is how many times you compound. So if it's quarterly, my N is a 4. I put it 2 places, here and here. Know that formula. I gave you that on your formula packet. What was your next one? 3? Okay, almost the same thing, right? Okay.
And we only have 2 more.
What's 2 on Monday?
Let's do on Monday.
I wrote it. But we could like move
Here we
it
can
over.
check it around because I had some technical difficulties. Monday, Monday you do 5 and 6.
Yeah, we can try it.
7 is due Tuesday, so if you get 7 done, we can go over whatever's left on Monday. And I want to spend a little time on limits, and then maybe we have an extra day to talk about whatever you want to talk about. Okay. Oh, 8 is important. 8 has your, right? Yeah. I forgot we had 8. Grant.